Welcome to question 12 from the 2020 TMUA paper 1. The question asks us to find how many real solutions there are to the equation 3 cos x equals the square root of x, where we measure x in radians. And we are given the options 0, 1, 2, 3, 4, 5 or infinitely many. Pause the video here and have a go at answering this question for yourself. Okay, well let's begin by making a sketch of the equation y equals 3 cos x. In order to sketch this, we're going to need to label all multiples of pi over 2, and we'll go up to 4 pi, so we'll do 2 full waves of cos x. So cos x starts at plus 1, and since we're multiplying by 3, this graph is going to oscillate between 3 and minus 3. So it will come down from 3, back up to 3 for 2 pi, and then go down again and come back up to 3 at 4 pi. So it will look something like this. And now we want to think about where a graph of the square root of x will fit in on these axes as well. And then we can find the number of real solutions to this equation just by looking at how many intercepts there are between the two curves. Okay, well, what points do we know the square root of x has to pass through? Well, it must pass through the origin because the square root of 0 is 0. And what other interesting point will it pass through? Well, square root of x is always positive, so it's always going to be up here, and it's an increasing function. So we might ask, when does it pass through a y value of 3? Because obviously once it's passed through that, it's only going to keep increasing, so it's an increasing function, and therefore it will be always above this curve, so they will never intercept past that point. So indeed 3 is the square root of 9. So we know that the point 9, 3 must lie on the curve y equals square root of x. But where does 9 lie on this axis? Well, pi is slightly bigger than 3, so 3 pi is slightly bigger than 9, and therefore we can deduce 9 lies somewhere between 5 pi over 2 and 3 pi. So therefore we can draw the point on as here. And we know that therefore the graph of y equals square root of x must go through this point and through this point and then keep increasing so that it always has a y value greater than 3. So the curve will look something like this, and always to the right of this point the square root of x is going to be greater than 3, so it can never intercept this curve again. So we can look and we see there are 3 points of interception between the two curves here and no more further to the right of this, so therefore our answer is just that there are 3 interceptions between these two curves and therefore 3 real solutions to the equation 3 cos x equals the square root of x. So 3 is option D, so our answer to this question is option D.